Good morning, students. Today we are going to discuss about module number 2, that is network theorems. Here we are going to discuss about that Millman's theorem and problems on Millman's theorem. So first of all, here we are going to discuss about that Millman's theorem statement. The Millman's theorem statement states that when a circuit which consists of a number of voltage sources like V1, V2, V3 and so of Vn which are connected in parallel, having internal resistance like R1, R2, R3 and so of an Rn respectively, the arrangement can replace by a single equivalent voltage source as V and single resistance as R, which is connected in series with the load resistance RL. Then whose voltage source value V is equal to the formula like V1 G1 plus V2 G2 plus and so of an Vn Gn divided by G1 plus G2 and so of an Gn, and whose resistance R value is equal 1 by G1 plus G2 plus G3 and so of an Gn. So Millman's theorem is nothing but one simple technique which is used to reduce the complexity of the circuit when a circuit which consists of a number of voltage sources like V1, V2, V3 are connected in parallel, and these V1, V2, V3 again it is connected in series with internal resistance like R1, R2, R3 and so of an Rn. Then the group of all these voltage sources and its internal resistance can be replaced into a single voltage source like V and single resistance like R, whose voltage source value V is equal to V1 G1 plus V2 G2 plus or minus of Vn Gn divided by G1 plus G2 plus G3 and so of an Gn, and whose resistance R is equal to 1 by G1 plus G2 plus G3 and so of an Gn. This is the way how we can use that Millman's theorem as to reduce the complexity when a circuit which consists of more number of voltage sources which is connected in parallel along with its internal resistances, then the total entire combination has been simplified into a single voltage source and single resistance with the following formula according to that Millman's theorem. Now we are going to verify that Millman's theorem with the problem has been shown in the figure. So the problem is find the current and voltage across the load terminals using Millman's theorem. So we have to find out that current and voltage across the load terminal. Here the load terminal value they given, that is 9 ohm resistor. So I want to calculate that what is the current which is flowing through this 9 ohm resistor. I mean current flowing through the 9 ohm resistor is how much, and voltage across this 9 ohm resistor is how much. That too by using the Millman's theorem here I want to calculate. So I want to calculate that current flowing through the 9 ohm resistor and voltage across the 9 ohm resistor using Millman's theorem means I have to first of all use that, I want to convert all these voltage sources like V1. Here in the given problem V1 is equal to 12 volts, and V2 branch they are not given any voltage value, therefore V2 value I can take it as 0 volts, and V3 value they given it as 6 volts, so I can take V3 is equal 16 volts, and R1 value they given it is 2 ohms, that means G1 value can become as 1 by 2 ohms. R2 value they given it as 4 ohms, then G2 value can become as 1 by 4 mhos. R3 value they given it as 4 ohms, then G3 value can become as 1 by 4 mhos. So with this all formula I want to substitute in the problem. So step 1 already we did, that is by observing the figure how many voltage sources, how many resistors are there. Here E1 value 12 volts, R1 value is 2 ohms, E2 value is 0 volts, R2 value is 4 ohms, E3 value is 16 volts and R3 value is 4 ohms here. So now our step is to substitute all this data in the problem. So I am going to calculate first of all that G values. The G values here it is R is equal to 1 by G1 plus G2 and so on and Gn. Here G1 means 1 by R1, 1 by 2, G2 means 1 by 4, G3 means 1 by 4. I want to calculate its R equivalent value. So if I want to calculate its R equivalent value means, now R is equal to all these values, therefore R is equal to 1 divided by all the values like 1 by 2 plus 1 by 4 plus 1 by 4. So this value can becomes that is 1 by R equivalent. If I take, it comes 2 plus 1 divided by 4. If you do that, simplify here, the value can become as 1 ohm, that is R equivalent value is equal to 1 ohms. Let me check what about that, what equivalent voltage E. The equivalent voltage E formula, by applying the Millman's theorem, we can write that sigma of E I is equal 1 to N, that is equal EI divided by RI divided by sigma of I is equal 1 to N divided by 1 by RI. If you expand this formula, the formula can become as here. So now the overall voltage E is equal E1 divided by R1 plus E2 divided by R2 plus E3 divided by R3, or we can write as like this, or we can also write this, the overall voltage E is equal V1 G1 plus V2 G2 plus V3 G3 divided by G1 plus G2 plus G3. We can use any one formula and we have to substitute that all the data whatever here we have. If we go through that to substitute all the data whatever here we have, now I am going to substitute that E is equal 12 by 2 plus 0 by 4 plus 16 by 4 divided by 1 by 2 plus 1 by 4 plus 1 by 4. Here 12 by 2. 12 by 2 means it becomes as 6. 0 by 4, anything 0. 16 by 4, 4 4 is a 16, 4. Divided by 1 by 2 plus 1 by 4 plus 1. 1 by 2 plus 1 by 4 plus 1 by 4. It comes as 1. Because if you take that LCM as 4, here 2 plus 1 plus 1, it becomes 4 by 4 and it is equal to 1. If it is 4 by 4 and it is equal to 1, denominator means then numerator 6 plus 0 plus 4 divided by 1. It is 10 by 1. So the overall E is equal to 10 volts and already we are calculated the overall R value. The overall R value here we got that is 1 ohm. Now substitute that overall value R is equal to 1 ohm and E is equal to 10 volts in the Milman's theorem equivalent circuit. Milman's equivalent circuit, from the statement of Milman's theorem already I was shown that this is the equivalent circuit. In the place of here E value, R value, RL value I am substituting. If I am going to substitute E value, R value and RL value, it becomes E value I am placing here it as 10 volts, R value, R equivalent value 1 ohm and RL value in the given problem they given it as 9 ohms. If you go through that the given problem here they given that here 9 ohms. If I am going to substitute all the data, then what is the current? Because they asked to find out what is the current flowing through the 9 ohm resistor and voltage through 9 ohm resistor. So now I am going to calculate the current flowing through the 9 ohm resistor, that is load current IL, is equal E divided by R equivalent plus RL. E means 10, R equivalent means 1 and RL value is 9. 10 by 10, IL value is equal to 10 amperes. The current flowing through the 9 ohms is equal to 1 ampere means what is the voltage across 9 ohms? The voltage across 9 ohms is IL into 9, that is equal 9 volts. The voltage across 9 ohms is equal 9 volts and the voltage across 9 ohms is equal 1 amperes. These are the solutions for the given problem. Thank you.